Hello students, now we will discuss a miscellaneous problem. Next problem is problem number 31. Find the value of square root 1 plus square root 1 plus square root 1 plus so on up to infinity, and hence find the value of square root a plus square root a square plus square root a to the power 4 plus square root a to the power 8 plus so on up to infinity. Now solution is, let the given expression is equal to x. Therefore x is equal to square root 1 plus square root 1 plus square root 1 plus so on to up to infinity. Let it be equation number 1. That is, we are given or x is equal to square root 1 plus square root 1 plus square root 1 plus so on up to infinity. Therefore x is equal to square root 1 plus the remaining factor from equation number 1. This is equal to x. So put its value is equal to x. So we get x is equal to square root 1 plus x. Now squaring both sides, so we get x square is equal to 1 plus x square root whole square. Now square root and square cancel each other, so we get x square is equal to 1 plus x, or x square minus x minus 1 equal to 0. Let it be equation number 1. So this is the quadratic equation in x. Now comparing with the standard quadratic equation, ax square plus bx plus c equal to 0. So we get a is equal to 1, b is equal to minus 1, and c is equal to minus 1. Therefore, the discriminant is given by capital D is equal to b square minus 4ac. Putting the value of a, b and c, this is equal to minus 1 whole square minus 4 into 1 into minus 1. Now minus 1 square become plus 1, so it is equal to 1, and minus into minus become plus, so it become equal to 1 plus 4 equal to 5, which is greater than 0. That is, discriminant is positive. Hence roots of the equation are real and given by x is equal to minus b plus minus square root d upon 2a. Now putting the values, this is equal to minus into minus 1 plus minus square root 5 whole upon 2 into 1. Now minus into minus become plus, so this is equal to 1 plus minus square root 5 upon 2. Now neglecting the minus sign, as from equation number 1, x cannot be negative. Therefore, x is equal to 1 plus square root 5 upon 2, or x is equal to square root 5 plus 1 upon 2. Let it be equation number 3. So this is the value of the given first expression. Now square root a into the given expression square root 1 plus square root 1 plus square root 1 plus so on to infinity. This is equal to square root a plus a into square root 1 plus square root 1 plus so on up to infinity. Taking a into inside the square root. So this is equal to square root a plus square root a square plus a square into square root 1 plus square root 1 up to infinity. That is, taking the a into within the square root, it becomes a square. So it is equal to a square plus a square into the remaining factor. And again, take this a square within the square root. So it becomes a to the power 4. So this is equal to square root of a plus square root a square plus square root a to the power 4 plus a to the power 4 into the remaining factor. That is a square. When taken into within the square root, it becomes a to the power 4. Similarly, and so on, we get this is equal to square root a plus square root a square plus square root a to the power 4 plus square root a to the power 8 plus so on up to infinity, or square root a plus square root a square plus square root a to the power 4 plus square root a to the power 8 plus so on to infinity. This is equal to square root a into square root 1 plus square root 1 plus square root 1 plus so on up to infinity. From equation 3, this is equal to square root 1 plus square root 1 plus square root 1 plus so on up to infinity. This is equal to root 5 plus 1 upon 2. So put this value. So we get, therefore, square root a plus square root a square plus square root a to the power 4 plus so on up to infinity. This is equal to square root a into square root 1 plus square root 1 plus square root 1 up to infinity. Putting its value, this is equal to square root a into root 5 plus 1 upon 2, or this is equal to square root 5a plus square root a whole upon 2. That you open the bracket. So this is the value of given second expression. Similarly, we can also prove square root 3 plus square root 3 square 9 plus square root 3 to the power 4 81 and so on up to infinity. This is equal to square root 3 into square root 1 plus square root 1 plus square root 1 up to infinity, or putting its value, this is equal to square root 3 into square root 5 plus 1 whole upon 2. So multiply by root 3. This is equal to root 5 into 3 plus root 3 upon 2, and this is equal to square root 15 plus square root 3 whole upon 2. So by this method we can find the different types of expression. So thank you very much.